Hello, welcome to our next video. This is going to be our exponent rules video. You're going to notice in here I had already pre-written some of the notes. That's just so that this video isn't super long for the writing process. So we're going to go ahead and get started with product property. So when I open this up, you're going to see something. You're going to see two x's and then two separate exponents. The purpose of the exponent rules is still the combining of like terms. But whenever exponents are involved, we have to do that a very specific way. So let's go ahead and get started. You can see two x's that are being multiplied because they're right next to each other with no separation of addition, subtraction, or division. So you always assume multiplication for those cases. So I have two x's that are being multiplied, and then they have their exponents m and n. So this is the exponent rule of when I multiply, keep the base and add the exponents. Okay, now what does that mean? You kind of have to go back to your memory of what it means to be a base versus an exponent. The base is always the number that the exponent is attached to. So at this time we have an exponent of m that is attached to an x, and then an n that is also attached to an x. So therefore our base in this case is the x, which would make m the power. Okay, power is another term used for exponent. I just want to make sure I'm using all of those terms so that way nothing ever surprises you. Now, obviously our bases are the same. They're both x's, so I can do something with those exponents. So that way, instead of having two separate bases, I can actually combine those and combine those exponents. So we're going to do that in these examples here. Now here they really laid it out for you. They say x to the power of 5 times x to the power of 7, which is a clear indicator that you are multiplying because of that dot in the middle. But I also want you to be prepared. They can sometimes just set them next to each other, which is honestly the most common way that they do this. So when I multiply, keep the base, add the exponents. Again, you're just combining like terms, but we're having to do it a very specific way. So because the bases are the same, I cannot express that enough. The base either needs to be the same variable or it needs to be a coefficient, or not coefficient, a constant. So with that being said, because the x's are the same, I can do x. Because those bases are being multiplied, I can take 5 and add 7. See how I got rid of that base, that second base, and now I just have one base and I have my two powers, which then will condense that to x to the power of 12. And that is what that means. I have two bases being multiplied together. They're the same. Therefore, I can take those exponents and add them together. Now, exercise the same thing on number 2 where it says g to the power of 2 times g to the power of 4. Oh, they are multiplying and I have exponents. So when I multiply, keep the base, add the exponents. We're going to keep our base and add our exponents to give us g to the power of 6. Perfect. Now, if you notice something on number 3, which I hope that you did, you have a d times a d to the power of 8. They like to kind of trick you with this one because you see a d and you think, oh, there's no exponent, I'm good to go. No, there is an exponent. Remember, mathematicians are lazy. There is an invisible 1 right there. So don't let them trip you up with that. Everything has an exponent. It just has to either be shown numerically or it's invisible and you have to know it's there. So now bases are being multiplied. When I multiply, keep the base. Oh, let me change colors here. Keep the base, add the exponents. Now I'm going to graduate you up a step. I'm not going to make you do this process. 1 plus 8 is 9. And that is what it means to have bases being multiplied together. Now moving on to the power of a power. So here, notice now I only have one base, but I still have two separate powers happening. So this one is when I have, oh, wrong color, I'm sorry. When I have a power to a power. Now let me explain what that means real quick. You have a power, and then on the outside of the parentheses, you have another power. That's power to a power. keep the base, and multiply the exponents. So a while ago we weren't able to multiply because the bases were being multiplied themselves. In this case, the exponent is being multiplied. So notice I'm writing down these when I statements. Makes it very personal. That is how I even got through this whenever I was in your shoes. I had to say these statements out loud to myself to really understand what I was doing. I would recognize, oh, that's a power to a power. When I have a power to a power, keep the base, multiply the exponents. So that's essentially what we're about to do. On number 4, you have x to the power of 2 times the power of 3. So because I have an x as my base, we're going to rewrite. Let me make sure I get the right color here. Y'all know how I am about my colors. X. Now I have a 2 power to a power of a 3. So it's going to be 2 times 3. So that will equal x to the power of 6. And that is what that means. Have power to a power, take it, multiply it. Now you have your new one. We'll do the same thing on number 5. You have f to the power of 7 to the power of 4. That is a power to a power. When I have a power to a power, keep the base and multiply the exponents to give us our new f to the power of 28. And then of course on the last one, we graduate you. We have c to the power of 5 to the power of 2. Power to a power, keep the base, multiply the exponents. C is the base, and 5 times 2 is 10. And that is what that rule means. On to the next one, power of a product. Open that up. Notice here I still have parentheses, but this time I have 2 separate bases. It will not always be that way. Sometimes you will have a number, sometimes you will have a variable, but the process never changes. Now this one is called power of a product because you have a power to something being multiplied together. So when I have a power of a product, distribute the power to each base. So now we kind of have to dive back into that distributive property where I have to share every single thing with my exponent. So I got to take my exponent, I have to share it to the power of the x. Not to the x, to the power of the x. And then do the same thing with my y. Okay, now obviously variables tend to freak us out, so I'm going to do this with actual numbers so that way it makes the process a lot easier. So x times y to the power of 3. Take that 3 and distribute. Now hopefully you remember what I said about what everything has. Everything has an exponent. It's just, do you see the exponent or do you not see the exponent? So if you need to rewrite to where you can see that everything has an exponent, I would encourage you to do so that way you know what you're distributing to. Okay, so we have our 3. I'll change my color real quick. We have our 3 and we need to share it with the other exponents because these are exponent rules. So now when I do that, remember distribution means to multiply. So whenever I do that, that changes from x to the power of 1 to now x to the power of 3. And then y to the power of 1 to now y to the power of 3. And if you're wondering, Miss B, well, how'd you get that? It wanted me to distribute the 3. The x is the base. Therefore, it has to have an exponent of 1, and 1 times 3 is 3. And then the same rule applies for the y. So again, on this next one, number 8, you see jk to the power of 5. Well, Miss B, is it going to be 5j? No, because that 5 is an exponent, meaning I have to share to the exponent attached to each one of the bases, which in this case is 1. Won't always be that way. Sometimes there is numbers there. So you like, for example, it won't always be to the power 1. Sometimes it'll be to the power 2 and you'd have to do 5 times 2. But in this case for notes, we're going to start simple. 5 times 1 would turn that. I'm going to rewrite it over here. Is j to the power of 5. And then, of course, k to the power of 1 is now going to be k to the power of 5. And that is what that looks like. Now, if you don't need this step because you recognize, oh, those have exponents of 1, that is the point I'd like for you to be at. So if you feel confident on number 9, distribute that 8, r to the power of 8, s to the power of 8. Oh my gosh, that 8 is ugly. Let me pause this real quick. Listen, y'all, I don't know what I would do without my little handy dandy friend Whiteout, okay? So r to the power of 1 times 8 is r to the power of 8. S to the power of 1 times 8 is s to the power of 8. And that is what it means to have a power to a product, okay? Moving on to quotient property, which is how I see it most commonly tested, is now we have a quotient. Now hopefully you're able to kind of see what this is, and then hopefully you also remember what it means to have a quotient. Some sort of division is happening. So when I divide, keep the base and subtract the exponents. Now number 10 says x to the power 7 over x to the power 3. Sometimes in our brains we do not associate fractions with division, but how you can always tell it's division is you have this bar, that's indicator number 1, but this is actually a division sign just with terms instead of dots. So what I mean by that is literally there's the bar, and instead of the 2 dots, they replace it with x to the power 7 and x to the power 3. That's how I was always able to decide if I'm going to be dividing here. Okay? Now, with that being said, we are going to subtract. Now, how you do that is very, very, very important. When you have a quotient rule, you have to make sure that the bases are the same, number 1. In this case, the base is the same. We have an x. Perfect. Now, the order of the subtraction. It has to be the numerator minus the denominator. It cannot be in the reverse order, and there's a very specific reason for that that we will get into in actual examples that we do together in class. But as far as this goes, you have to take the numerator's exponent and subtract the denominator's exponent, which would then give me x to the power of 4. Perfect. If there was a negative exponent, we would have had to change some things up. But because it's positive, I get to stop right there. You always want to have positive exponents. That is it. No negatives, no nothing. Always needs to be positive exponents. So now number 11, p to the power 8 divided by p to the power 5. Bases are the same. Perfect. 8 minus 5. Because when I divide, keep the base, subtract the exponents. That will then give me p to the power of 3. Next one, last one. Going to graduate you a step. We're not going to write out this process. V to the power of 9 divided by V to the power of 3. When I divide, keep the base, subtract the exponents. V to the power of 9 minus 3, which is 6. Just like that. So that is the quotient rule. Now let's get into what it would have happened if we would have gotten a negative exponent. So negative exponents are not allowed. So when I have a negative power, take the reciprocal of the base and the exponent. You are not allowed to have negative exponents. Those will never be allowed. You always want to end with something that is positive. Okay, so now what I mean by this is you have number 13 says x to the power of negative 4. That is currently, if I were to write it like a fraction, over a 1. okay? Now, the reason for that is because by putting it over 1, that doesn't change the value. It is still x to the power of negative 4. But because I have a negative exponent, I have to take that negative power and compute the reciprocal of that entire term, so that way I could turn that exponent from being negative to now it will be positive. So to do the reciprocal, you cannot forget what reciprocal means. That means that you do the flip. You flip what you currently have. So instead of x to the power of negative 4 over 1, you're going to have 1 over x. But because I did the reciprocal, I can change it to a positive 4. And you see how you just took that negative exponent, you got rid of it, and changed it to, I hope I said negative exponent. Yes, take that negative exponent, you did the reciprocal, and you turned it to a positive exponent. So that is what I mean by you're not allowed to have negatives. You do have to change them. So then the same thing here. That h to the power of negative 2. Now, if it had just been h to the power of 2, I could have left it, but it's not. It's a negative 2. So I have to remember that that is over 1. Therefore, whenever I do the reciprocal, meaning I flip it, that would be 1 over h to the power of 2. And I do want to say this, it's not always going to be a 1 down here. It could be a number. You just have to pay attention to what it is. And we, of course, are going to do examples in class that go through that. I'm just trying to give you the baseline of what we're doing. And then 15 says a to the power of negative 7. I'm going to graduate you from this step and hopefully just go straight to the answer, which would be 1 over a to the power of 7. And that is what it means to have a negative exponent. You're not allowed to have a negative power. You must change it to the positive version. Now, the zero property, probably the most simple property that we have, is when I have 0 as the exponent, the term will equal 1. So anytime you have 0 as an exponent, which is why I said every number has an exponent, whether it's written or whether it's invisible. So when you have a 0 as an exponent, no matter what the base is, the value will always be 1. So like, for example, if I were to go on our calculator here, and I don't know, let's do, oops, sorry, my button. Let's do 67 to the power of 0. I want you to watch what happens. We're going to get the output of 1. Well, what if I did 6.7 to the power of 0? Let's see what we get. Oh, would you look there? I get a 1. No matter what I type in here, I'm always going to get the power of 1. Or not the power of 1, the answer of 1 with the power of being 0. So on these, x to the power of 0, no matter what you put, it's going to be 1. F to the power of 0, no matter what it is, that power of 0 turns it to 1. And then the same thing for W. So that is the baseline of your exponent rules. Those when statements will really help you because it makes it more personal to you. Hope you enjoyed this video. Bye.